this is Station 1. We're talking about grassland-shrubland transitions in future decades. Phenology is actually the study of seasonal transitions, and this applies to both plants and animals. We're going to be talking today mainly about plants and how kind of that phenomenon, or the kind of aspect of the natural history of grasses and shrubs that have kind of coexisted in these landscapes for a very, very, very long time. And this land that we're standing on now is historically dominated by C4 grasses, and it still is in many places, but you see the increase in the number and abundance of shrubs, in this case mesquite shrubs. And so there's been a lot of work that's been done to kind of study the rates and patterns of that change and the processes governing those changes. And the changes, I mean mainly the increase in shrub abundance at the demise or at the expense of the coexisting C4 grasses. But one of the aspects of this kind of phenomenon that hasn't really gotten as much attention is the role that phenology may play, the seasonal activity patterns of the grasses and the shrubs. And so we are using kind of digital cameras that I'm going to call phenocams, and you're going to get to see a phenocam at the stop where you talk about the wind erosion network. What did you guys talk about?
Just did.
You just did? Okay, did you see the camera on the tower? Okay, so those are the cameras that are used to collect the data that you see, this picture that's on the front of the page. And the yellow and the white outlines are delineations that I made to derive patterns for the mesquite shrubs that are in that image view and the grasses, the black grama grass that's in that image view. And then, so the cameras are mounted, they're just security cameras. You can essentially calculate, they take photos many times during the course of the day, and you can derive very easily a greenness index, which is essentially the percent of green within these yellow and white outlines. Okay, so it's an average, and you have a daily value, which is really amazing when you consider the cost of getting a person out in the field to look at the condition of the plant, right? So we have the cameras observing these patterns of greenness. And so the graph, the brown is the line for shrubs, and the green is the line for mesquite. And then below that, you see the daily rainfall. And this is for a grassland site. It's one of our long-term research sites. And so there's two things I want you to notice here. Mainly that mesquite has a much longer growing season than the grasses do, okay? And then the second thing is the intimate tie or link that the grass greenness has with rainfall. We have a consistent quantitative metric that we can use with a camera that's in the field, right, to kind of quantify these things. And we are looking at the role of temperature and rainfall and relative humidity or vapor pressure deficit on the timing of these patterns. That's not really what I'm going to talk about today, but we are evaluating that. So one of the things that, if you flip the graph over, I mean, we all know, or many of us do, if you are familiar with this area or live here in Oakley, so it's very variable. Rainfall is very variable both within a year and between years. And Osvaldo is going to talk eloquently about a beautiful setup that they have to kind of demonstrate some of those patterns. But with the line graph at the top is just to kind of show we've gone from really, really dry years in 2000 to 2003 to very wet years in 2006, 7, and 8. 2004, 6, and 8, really, right? And I point this out because we also have the luxury of a long-term perspective on plant phenology as part of the LTER, the Long-Term Ecological Research Station. And so since 1993, they've been collecting data on the timing of initial growth, so when grasses produce their first leaves or mesquite produces their first leaves, when they flower, and when they produce fruit, okay? And so the data period for which those data have been collected have been over these drought years and these wet years, okay? And yet, as you look at the histograms, and all I really want you to look at are the colors and the shapes of those histograms. So what is the mesquite leaf out, like the timing of leaf out, the month that mesquite leaves out? It's really consistent. Over 70% of the year site observations that we had in this 24-year study, mesquite leafed out in April, no matter what the rainfall was like. So it's not tied to rainfall. It's consistency both in leaf out, production of flower, and the production of fruit. It's much more consistent than black grama grass, which is the set of graphs on the left side. And that gives it a competitive edge that we haven't really even explored as we're talking about shrub encroachment. We've got differences in available water, the depth to that water, I mean, there's just a lot of differences between the two, the competitive ability and the resilience, I guess, of the two species. And this is an aspect of it that's relatively, hasn't been explored that much. And so this is more important as rainfall becomes more limiting, or rainfall, I guess it's really more the variability, the timing, and the amount of rainfall from year to year. Is really important with the consistency that mesquite is demonstrated over the long term. And this is really important if you're planning shrub eradication treatments, herbicide applications as part of Restore New Mexico is one of the programs that Brandon talked about today. There's a time when they're most susceptible to the deleterious effects of those herbicides, is when they put out new leaves, right? And so the timing of that is important to know when you're planning those treatments. And so there's actually real life applications for some of these data that were kind of insights that we're generating from long-term data as well as the more recent data with bean cams.
So thank you all. This is a perfect gift for me. Imagine being in my favorite place in the world with these lifelong friends and new friends. So as a way of introduction, I pulled 4 figures here. This is the map of the southwest of the United States, correct? This is the change in temperature that was measured in the last 50 years. So this is change in temperature from 50 years ago till the present time. So where we are looks like it's now what? Hotter than it was before. The next one is the change in, and the scales are in the bottom. The scales is the next one is the variability in temperature. See where we are. Then go one step one. The third one is the change in precipitation. So where are we? What color is where we are?
On the mean precipitation?
And the mean precipitation looks pretty red to me. What happens with the variability one?
Really red.
Really red. So what is your take-home message? What happened in the last 50 years with this region where we are here? It became hotter, drier, and more variable, correct? So this is just to put us in context. So most of the global circulation models sort of point out in the same direction. We're going to get certainly hotter with in some uncertainty regarding the amount of precipitation and certainty that it's going to become more variable, correct? So what I'm going to talk to you now briefly is our multiple experiments. We're trying to assess the effect of precipitation on the functioning of this ecosystem. We think that the availability of water, that the increase in temperature is going to be mostly seen through changes in water availability, not the direct effect of temperature itself. So we came up a long time ago with this design. This is a rainout shelter here that in this is a demonstration for you. We have 164 distributed all over the Jornada range. This particular one is intercepting 80% of incoming precipitation. So it rains only 20% of what it rains outside, correct? The water that is captured by the rainout shelters goes into that gutter. From the gutter goes through that temporary tank where we have a switch, a float switch, and a pump that is driven by that solar panel. So this is how it works. So we create a gradient from very dry conditions to very wet conditions. And we've been doing this experiment, highly replicated all over the Jornada, 164 plots, and here are the results. I'm going to share with you some of the results of 12 years of experimentation. So here in the bottom, we have years of since the beginning. We started this experiment 12 years ago in 2006. And here we have the production of grasses, relative to the control. And these are, the yellow line is the drought plots. And what I told you that we have 164. And then this is the irrigated. And there are sort of 2 important messages out of this figure that I want to convey to you. First one is that the effect of the rainfall manipulation, either the drought or the irrigation, increases through time. And so look, if we would have done the experiment for 1 year, from 2006 to 2007, we would have concluded and written a paper saying that drought doesn't have any effect in the Chihuahuan Desert. And the irrigation had some sort of a positive effect. And then we saw that as the time went by, the effect of drought and water increased through time. And then by 2011, 2012, we thought this is what happens. Then the system stabilized. This is the production. And then we saw that by 2014, the drought treatment started completely collapsing. There's a sharp decrease in the production of grasses and a sharp increase in the production of those irrigated plots. There are 3 different conclusions that we could have achieved based on the length of the experiment. If we would run the experiment for 1 year, we would have said that there's no effect of drought. If we run it for 8 years, we would have said there is a 50% decrease in grass production. But if we run it for 12 years, we see the grass is completely collapsing and unable to respond. This year, 2014, was a particular wet year, and the grasses collapsed. So this is what happened with grass production. Then I want to move you to the other graph to the right. Is the production of shrubs, and you see the same color patterns. So the first 10 years, there was no significant effects, and towards the end of the year 2015, we started seeing significant differences in a very strange pattern that I was forced to accept. That's what the data were showing us. The drought had a much higher shrub production than the control and higher than the irrigated. And this is in part a consequence of we think it's not that shrubs like the drought, but they really love the demise of their competitor, the grasses. So it is the decrease in the grass biomass that sort of allow more water to get into the deeper layers that are only produced by. So now I'm going to shift to the back of the page, where we're going to look at the effect not of precipitation amount, but its precipitation variability. This is the work that Lau led, and what we did is this same setup, but we flip it each year, and we did that for 10 years. So this plot received drought 1 year, irrigation the other year. So you understand that the mean is the same, because one was minus 80, the other one plus 80. So, and after 10 years, we found no difference in the amount of precipitation, but an increase in variability. The variability increased from 50% as the natural to 160% coefficient of variation. And that resulted in a sharp decrease in the production of grasses, sharp decrease in total production, and an increase in grass production. So the grasses not only benefited from the drought, but benefited by the increase in variability. So in synthesis, we are going to be in a world that is going to be hotter, drier, or more variable. And how is this going to look when we come here in 50 years?
Dominated by shrubland.
Probably. They're going to be much more. They're going to have more work for us to walk through the shrubs. How you can extrapolate these results. So independently of this, we have a project that is funded by the National Science Foundation called the Research Coordination Network, where we have the same experiments replicated over 100 locations worldwide, in North America, South America, Africa, Australia, Europe, Asia. And we are trying to assess the sensitivity, how much they change to drought.